now to revise those laws of exponents. Okay,
Yes.
and after once we revise these laws, then I will ask you to solve these questions. All right, you write the heading laws of exponent and quickly recall them, revise them. Okay. Okay, I'm sharing the screen now. Okay, put the heading laws of exponents. Okay, what are the laws of exponent that deals with the exponents? Okay, what is exponent is now well clear to us, and that's why it is very easy for us to understand laws related to it. Okay, laws of exponents. First of all, we need to understand what the exponents are, that we have already understood, and exponents are actually the power raised to something. In general, we write it like x raised to the power n, and when we write anything like this, x over is known as x over here is known as base, and m over here is known as power raised to base, or generally we call it exponent.
Yes, sir.
Yeah, I think you must be okay with this. Okay, let's say I'm writing 3 raised to the power 5 here.
Sir, can you please allow me to record?
Yeah, all right. I'm just making you co-host, and you will be able to recall it. Okay, if I'm writing 3 raised to the power 5, here I will call 3 to be my base.
Recording in progress.
And 5 to be my exponent. All right.
Yes,
And
sir.
what does it indicate? It indicates base is that much times. If I'm writing 3 raised to the power 5, that means base is 5 times multiplied.
Yes.
That means base is multiplied 5 times. This is the meaning of base that we must understand from today onward. And here if we want to figure out the value of 3 raised to the power 5, that is coming out to be 3 3s are 9, and again 3 3s are 9, you will write it 9, and it is also 9. We got 81, and then multiplied with 3, we got 243. Okay. Similarly, we can figure out any such value. You can
Yes.
figure out any such value.
Yes.
Okay. How can you figure out any such value? Okay, let's say I'm just giving you. I want you to figure out the value of 2 raised to the power 6. Can you tell me the value of 2 raised to the power 6? Okay, 2 raised to the power 6. Here,
28, sir.
yeah, here base is 2 and power is 6, and if power is 6, that is exponent is 6, it simply means I have to write 2 6 times, isn't it? I have
Yes.
to write 2 6 times, and if I have written 2 6 times, I can multiply. We can multiply like this: 2 to the 4 to the 8, and then 2 to the 4 to the 8, and 8 times 8 is actually 64. Okay, and what about laws of exponent? This is the basic of exponent that we have covered, and then we covered laws. I'm quickly helping you to recall all these things. Under laws, the first law tells that if you are having power of the exponent as 1, you will get the identical value. There will be no change. You can call it identity rule, or you can call it power exponent 1 rule. It's up to you. You can call it exponent 1 rule or 1 exponent rule.
Yes.
What happens in 1 exponent rule? If you are considering power raised to base 1 or power raised to something 1 or exponent of something 1, you will get the value itself. You will get the identical thing. Let's say if I'm considering 10 raised to the power 1, I will get 10 itself. Okay. That is
Yes.
why we call it identical rule or the exponent rule, 1 exponent rule. And similarly, we have 0 exponent rule. What happened in 0 exponent rule? Can you tell me what is the value of x raised to the power 0 or something raised to the power 0?
1, sir.
Exactly, it is 1. And that thing it may be any value, maybe 5, you will get 1, maybe 5,000 even, it will be 1 only. Okay, you need to remember it. If exponent is 0, we will get value equal to 1. Similarly, there is a rule, if you are just multiplying two such exponents, base raised to the power raised to exponent x raised to the power m, y raised to the power n. We are multiplying such two values in which we are having base as well as exponent. What happen here? If base are different, the rules may be two rules may exist here. What are those two rules? In first rule, base may be different, exponents are same. In next rule, base may be same and exponents are different. Okay, let's say right now I'm considering this rule here. If base are okay, first I'm considering base are different and power are same. What happen here? In such a cases, we multiply these base first and we take this power. Okay, I'm considering an example for this so that you can observe it with an example. Let's say I'm having 4
Power
raised to the
3,
power
4
2.
power 3.
Yeah, let's say I'm having 4 raised to the power 2 and I'm also having 3 raised to the power 2. Here what we observe here is we are having same exponent. Okay, we are having same exponent, but these bases are different. One way is there that tells that you solve 4 raised to the power 2, you solve 3 raised to the power 2, and then you know the value of 16 times 9 is 144. This is one way. The another way is you make use of this property. How will you use this property? First you will multiply your bases and you will consider that same power, and here that same power is 2, that means 12 raised to the power 2, and we all know the square of 12 is 144. These are two ways to solve this, but generally we are going to apply this particular rule in which we use the rules or laws of these exponents. Another law, same type of law is there in which bases are same but power are different and we are multiplying them. If bases are same but power are different and we are multiplying them, what happens if this happens? Power are different now, bases are same now. What happens here? Can you tell me?
Power and bases are different.
Yeah, if such thing happens that power are different, that means exponents are different but base is same. What actually happen in this case?
Yes.
What we do in such scenario? In such a scenario, we just
Yes.
add up the powers, add up the exponents. This is the thing.
Exponent, like, yes.
Yeah, we add exponents. All right, we can consider an example, no issue. I'm considering an example here itself. Let's say I'm having 3 raised to the power 2 and I'm having 3 raised to the power 3. As per this rule suggests, we have to add these two powers, these two exponents, and we will get 3 raised to the power 5, that is equivalent to 3 times 3 times 3 times 3 times 3, and that is further equivalent to 3 3s are 9, 3 3s are 9, that means 9 times 9 81, and last one 3 is there, 81 times 3 is 243. Okay, in this way whenever we come across such scenario, we just add the powers. What do we do here? We just add powers. Okay, now the next rule I'm just going to explain to you. Okay, next rule. I want you to understand next rule.
Yes, sir.
Okay, next rule is related to the related to quotient. Here I have applied product rule. We have just multiplied two such things.
Yes, sir.
Okay.
Hello, sir. Can you hear me?
Yeah, sure, I can. Okay. Okay.
Yes, sir.
Okay, next thing is you just divide. If you are having these exponents like this, x raised to the power m and
Recording stop. Recording in
x
progress.
raised to the power n
Yes.
written like this. If something is written like this, what we do here? We just subtract these powers. Let's say I'm having 2 raised to the power 5 written and it is divided by 2 raised to the power 3. What we can do here is we can just subtract these powers and the answer is going to be 2 raised to the power 2, that is 4. Similarly, one rule is there: when bases are different but power are same, like this. Bases
Yes.
are different and power are same. In such a scenario, we can first divide base and then we can consider the same power. Let's say I'm having 8 over 8 raised to the power 4 is there, 4 raised to the power 4 is there. We can solve it like this: 8 over 4 raised to the power 4. That is going to be 2 raised to the power 4. And 2 raised to the power 4 means 2 to the 4 to the 8 to the 16 is your answer. Okay, I'm explaining all these laws with an example so that you can well clarify it and properly observe it.
Yes.
I think you must be okay with all these explanation that we have gone through. Okay, okay, some rules are still there, but they are enough. Okay, one more rule is there, the power rule. The power rule. What happens in this power rule? In this power rule, if I'm having x raised to the power m raised to the power n, then we can just multiply these two powers or these two exponents. It's
Yes.
possible to multiply these two exponents. Okay, let's say I'm having 2 raised to the power 2 and then we are having whole power raised to 3. There is two ways to solve this. There are two ways to solve this. One way is there in which we can just use this power rule. Okay, Pradum, the first way is there in which we can just use this power rule and we can multiply these two power and we will get 2 raised to the power 6.
Sorry, so something is
Okay,
happening.
no
Just
problem. Yeah, all right. We got
yes.
2 raised to the power 6, that is equivalent to 64. This is one way. Another way is also there in which what you can do, you can just solve this first, this bracket first, as we already did there in simplification. We solved the bracket. Similarly, we can solve this bracket first. We got 4 and then we can take power 3, that is going to be 4 raised to the power 3, that is again 64.
Yes, sir.
There are two ways to solve such a question. All right. Similarly, we have some exponent that are not in integral form. So far, I have covered those
Recording stopped.
exponents. I have considered those exponents which are actually integer. Now we will consider some exponents that are non-integral type. But before you solve these questions, I want you to appear these. I'm just allotting some questions. Okay, solve as your class work. Right now you solve them. The first question I want you to solve: 2 raised to the power 4 multiplied with 2 raised to the power 3. I want the answer from your side. 3 raised to the power 2 divided by 3 raised to the power 4. Okay, some more rule may be there. I will just tell you. I just want you to understand these rule as well. If I'm having any power in minus, we can write it as 1 over x to the power m. If I'm having something written like this, power in minus and it is in denominator, we can just shift them numerator with positive power. These rules are quite obvious rules. Okay, solve the third one. 3 raised to the power 2 raised to the power 3 and
Yes, sir. I'm so sorry,
okay,
sir.
no issue. Yeah, okay. Yeah, I have just given you some questions to solve. I want you to appear them. Okay, the eighth rule is there, that is x raised to the power minus. If I am having minus exponent, we can just change their order. If they are in numerator, we will shift them in denominator with positive power. If they are in denominator, we will shift them towards numerator with opposite power, with sign change in power. If it is a negative m, we will make it positive m. And in the denominator, right now nothing is there, that means 1 is there. Got it? I'm just presenting one more question, that is 1 over 2 raised to the power minus 3 and 1 over 2 raised to the power minus 2. Okay. I want you to solve these 4 questions first, and then we will solve some questions in which we are having powers or exponents which are not integral. They are something else. They may be in fraction. Okay. We will consider those cases today in which our exponents are not integral. If exponents are not integral, the powers are also known as index. We will use the word index here. All right. Okay, first you solve these 4 questions, then we will start with the new topic.
Sir, the third one I did not get, sir.
Third question you didn't get, or the third rule you said?
Third one, sir.
Yeah.
Third question.
Yeah, here the first one is 2 plus 2 raised to the power 4 plus 2,
Yes,
that
sir.
is
I
7.
got that 2 by 12.
What is the answer to this one? Actually 2 to the power 6 is 64, and then you will
Yes,
multiply, you
sir.
will get 128, isn't it?
Yes, sir.
And this is going to be 3 raised to the power 2 minus 4,
2
that is
minus
3
4
raised to the power
equals to
minus 2,
3
and that is
minus
1 over 3 raised to the power 2, that is 1 over 9. Got it? In the
Yes,
third
sir.
one, either we can do this thing, 9 raised to the power 3, that is 81 times 9, that is 729, or we can even do like this, 3 raised to the power 2 into 3, that is 3 raised to the power 6, and that will be 729. If you want to calculate, you can. Okay, these are 2 ways. Okay, in this question, the fourth one, first we will solve this part, and it will be 2 raised to the power 3. Then we will solve this part, it will be 2 raised to the power 2, and then we will use the rule in which we add these exponents, and it will be 2 raised to the power 5, and that is actually equal to 2 to the 4 to the 8 to the 16 to the 32. It's equal to 32. Okay, is it okay for you?
Yes, sir.
Okay, all right, it's good. It's good. Okay, now we will consider some conditions in which we are going to use surds. Okay, we are going to use surds now, and we will understand what is index of them. Okay, what are we
Recording
using?
in progress.
Yeah, surds I'm going to tell you. In surds we are having fractional power. In surds we are having fractional exponent. So now we are going to consider the same topic but with fractional exponent, and whenever we have fractional exponent, we call it surd, and we call it a surd the irrational root of an integer. Okay, what we consider, what can we call it? The irrational root of an integer, or the irrational root. What are the irrational root of an integer? It is basic thing, but you can consider the fractional power of an integer. Either you call it the irrational root, or you can call it fractional exponent. Fractional exponent. Okay,
Yes.
fractional exponents. But you can't simplify them into integer. Do remember that. You can't further simplify it. That is why surds are irrational number. Okay, do remember, surds are irrational number. They are not rational. I think you must be okay with rational and irrational number. Can you tell me what is difference between rational and irrational number?
I
All the
don't
real
think.
numbers are of two categories. Some of them are rational, some of them are irrational. What is difference between these two? Rational can be written as p over q, where p and q are integer and q is non-zero, but it can't be written in such a way. Rational numbers may be terminating. I think you must be okay with. They are non-terminating but repeating. Irrational number are non-terminating, non-repeating. They can't be written as p over q, and such numbers are root of any prime, which can't be further simplified, or root of any integer which can't be further simplified in any integral value. Okay, these are some basic things you need to understand. Here we are considering surds, and we need to understand that surds are irrational number. All kind of irrational number like root 2, root 3, similarly root 5, they can't be further simplified, they are surds actually. And if you want to understand their decimal values are actually, which kind of values they do have? They have non-terminating and non-repeating. They are not going to repeat anyway. As much as long you want to do, as long you long divide it, you will not be able to consider its termination. They are not going to terminate anyway, and they are not going to repeat anyway. They are non-terminating as well as repeating. But rational numbers may be either terminating or non-terminating repeating. We have covered this in much detail, and today we are considering exponents with fractional exponent, and here the basic thing is surd, and in surd we are here in position to conclude that they are irrational number, and as they are irrational number, they are non-terminating, non-repeating. I am writing in brief NTNR.
Yes. Yes, sir.
Okay, similarly root 3 is 1.73205008. If even you try to further get the values, you will keep on getting values, but they will not repeat anyway. Similarly for root 5, if we long divide or we consider the square root, we will be able to obtain its decimal, which is going to be this much. But we can't write them as p over q, we can't terminate them, we can't repeat them. They are going to be non-terminating, they are going to be non-repeating. Okay, they can't be written as p over q, in which p and q are integer and q is not 0. Okay, only rational number can be written as p over q, where q is not 0 and p, q are integer. So all these things are very much needed to understand. Surds are square root of number that cannot be simplified into a whole or rational number. Generally we consider square root under surds. Okay.
Yes, sir.
Yeah. And square root of which type of number? Which can't be further simplified. To remember that as well.
Yes, sir.
Surds are the square root of numbers that cannot be simplified into a whole or rational number. This is also a definition of surd. What will you write? Surds are the square root of numbers, square root of numbers that cannot be simplified.
Sir,
Yeah, tell me.
what if those which can be simplified, sir?
If they
with
can be
the-
simplified, you will not get surd, because you will get an integer. That's
Then
why.
what will get, sir?
Yeah, let's say I am considering root 4. This root 4 can be written as 2 times 2. And if inside surd, this is a rule of surd, note it down. If inside this square root I am getting something 2 times, I will just remove this surd and I will get only one value. That is why we can remove the surd if it is number like this. If you are having perfect number and it is inside perfect square, if you are having perfect square inside square root, inside this surd, you will get an integer. That is why we are saying surds are the square root of numbers that cannot be simplified into whole number or integer.
Yes, sir.
Got it?
Yes, sir. I got it.
or rational number, whole number or rational number. We can't simplify them. Okay. Okay, I think you must be okay up to this point, and we are further considering the concepts. We are going to cover the concepts based on these surds. A surd that has only one term is called a simple surd. There are different type of surds. The first kind of surds are simple surd, and in simple surd, what actually happen? I'm just
Like how to get a perfect square, so?
yeah, I will tell you. I will tell you the perfect square. What the perfect square are? Perfect square are actually those numbers which are actually the square of something. Okay.
Like how to get it, so?
Okay. We can just
Like
factorize.
how to get a square of one, how to get a perfect square? Like how much should it be multiplied to make it the perfect square? So
Let's say
like
okay.
for example, we take 1392. So
Let's say I'm taking 1392. Okay. In order to understand whether it is perfect square or not, we approach with a way that is called square root. We try to figure out its square root. We try to find out square root first. Okay, how can you figure out square root? Let's say you consider its factorization. You have to factorize it first. 2 times 6 is 12, and then you got 19. 2 times 9 is 18, and then it is 12. 2 6 is 12. Again you will divide it by 2. 2 3 is 6, 2 4 is 8, and 2 8 is 16. Again you will divide by 2, and you will get 2 times 1 is 2, and 2 7s are 14, and 2 4s are 8. Again you will divide by 2, 2 8s are 16, and 2 7s are 14. And now you can divide it by 3. 3 2s are 6, and 3 9s are 27. Okay. Now you want to figure out what to do to what to multiply to make it perfect square. Okay. You need to understand that 1392 is written as 2 times 2, 2 times 2, again 2 times 2. Okay, this is 2 times 2, and again 2 times 2. You need to figure out how many pairs are not possible. Here we are not having pair of 3, we are not having pair of 29. In order to make it perfect square, Pradyumna, please focus carefully. In order to make it perfect square, what you actually need is, you need one more 3. Do you agree with this? You need one more 29. Do you agree with this?
yes.
If you are having one more 3, what you can, if you are writing, you want 1392 square root, what can you do? You need to just understand that how many values are needed that make it perfect square. Okay, it is like this. What you can consider outside, you can consider 2 outside and again 2 outside, but you are having 3 and 29 that is inside this square root, that is inside the surd. But you want it to be, but you want to eliminate this surd, that means you need to multiply something. What you need to multiply here? What you need to multiply here? What you need to multiply in number? Tell me what you need to multiply in number. You need to multiply 3 and 29. And
Yes.
if someone asks how many, what is the value that you need to multiply, you can just tell us that 3 9s are 27, and 3 2s are 6, and 2 8. You need to multiply 87 more in this 1392 to figure to make it perfect square. Got it?
Yes.
Yeah. Okay. In this way we can solve such a question. Such a questions are also very famous, and they may be asked in any competitive or in your exam as well, that how can we make perfect square, or what to multiply. Even they can ask what to divide. If they ask what to divide, the answer is again same. We need to divide 3 as well as 29, so that 3 and 29 just vanish away or just get eliminated. That's why we need to divide as well with 87. If you will divide by 87, you will get a number that is reduced version of 1392, and if you are multiplying 87, you will get number that is somehow the larger number. But in such a case, you will get a perfect square, because all of them are making pair. When will you get perfect square? If you are making pair of all those numbers. If you get pair of all those numbers, none of them are single. none of them are single. If all of the numbers are in their pair, you will get a perfect square. Got it?
Yes.
Okay, I think you must be okay with this now. In order to make any number perfect square, all the primes involved must be in pair. None of them should be single. Okay, simple surds are surd that has only one term. If a surd has only one term, they are called as simple surd. Like root 2 is a simple surd, root 5 is a simple surd. They have only one term. Only one term, that means it is simple surd. Okay, after simple surd there may be pure surd. If you want to say something pure surd, that means completely irrational. Here they are also pure surd, completely irrational. They are completely irrational. Similar surd, there is a word similar surd. When will you call something similar? You will call something similar same common surd factor. Surd factor is same. The surd having the same common surds factor. Again, mixed surds. The surds are not completely irrational. Compound surds may be there. Addition, if you are adding something. Mixed surd may be there, in which rational and irrational are mixed. 2 root 3 is a mixed surd. And there may be a compound surd. In compound surd, what we do here? We just add 2 surds. Okay, all these are some basic things we must understand, we must know when we are considering this chapter in detail. Okay. Similarly, there are some rules associated with surd that are common to those exponent rule, and I want you to understand now. I want you to focus these rules now. Okay, the first rule is, if you are first rule is rule related to surd. The first rule is square root of a times b, if it is written, you can just consider them separately. Okay, this is the first rule. We can have an example for each so that you can understand them properly. I am considering example for each of them. Okay, let's say I am having an example like this. Let's say I am having root 18. If root 18 is written, I can write it, I can just factorize it. 2 9s are 18, 3 3s are 9, 3 times 1. I can write it 2 into 3 raised to the power 2. Now I can just write root 2 and I can write root 3 2. And if something is written in pair, you can just consider one value without surd, without square root, that is 3 root 2 you can write. In such a simplification, we need to understand this rule. This rule is needed in such a simplification, whenever we need such a simplification. Got it?
Yes.
Okay, similarly a rule is there that is related to division. If it is written like this, you can just divide them in this way. Let's say I'm having something like this. I want you to just solve this, and under root of 12 over 121. Yeah, can you solve this? You can just separate it as per the rule suggest, and this is written as 4 times 3, and this is 121, and 4. What is the square root of 4? Can you tell me this? If something is written as 2 raised to the power 2, then what you can do?
16, sir.
Yeah, okay, I'm just telling you one more thing. This surd means the power is 1 by 2. If I'm taking surd of x, that means power is 1 by 2. If I'm writing it root x, it simply means here 2 is written. If I'm not writing here 2 in this portion, if I'm not writing 2, that also means 2 is written. And
Yes.
if 2 is written here, that means the power is 1 by 2. So whenever we are using this symbol, that means the power is 1 by 2. Got it? And here the power is 1 by 2. You can even solve using that exponent approach. That means you are going to multiply these powers, and if you will multiply, you will get power raised to 1, and if power is 1, that means you will get 2. Under root 4 is, that is why under root 4 is 2. Okay?
Yes, sir.
Here as well, the under root 4 is going to be 2, and under root 3 is there, and root 121 is actually 11. Root 121 is actually 11, and that is why the answer is going to be 2 root 3 11. Similarly, many other rules are there. I'm going to tell you the third rule. if you are having, yeah, all right, if you
Yes.
are having written like this, b over root a is written, you can just multiply root a both side and you can rationalize the denominator. You can rationalize the denominator by multiplying root a in numerator as well as denominator. You know, the same thing can be multiplied in numerator and denominator. That's why we are multiplying, and root a times root a is going to give you a. This is also a rule of exponent. If the same thing is multiplied 2 times, you will write it a. But do remember, this is very important thing that I want you to remember here. The condition is, here if I am writing square root, if I am using this surd, that means the 2 is written here. Okay, if I am writing x, that means 2 is written here, and it also means the index is 1 over 2, the exponent is 1 over 2. Similarly, if I am using 3 here, it means exponent is 1 over 3. If I am using 4 here, exponent is 1 over 4. In such a cases, I have to indicate that 3 is used, index 3 is used. In first case, we even don't indicate, that means 2 is used. If I am writing root 3, it means 3 raised to the power 1 over 2. If I am writing 3, it means 3 raised to the power 1 over 3. If I am writing 2 here, it also means 3 raised to the power 1 over 2. So this can be used in two ways, but these are represented using their index here. Got it?
Yes.
Okay. As we have understood all these concepts, now we are in position to solve these questions that are here in front of you. I am presenting here in front of you, and I want you to solve these questions using the approach of exponents and approach of these surds and index. The power raised to surd, whenever you simplify surd and you consider a power, that is known as index.
Yes.
Okay, can you solve this, the first one?
So can I just
64
go to
raised
the
to the
last one and
power
come
1
see?
over 2. Even it can be solved very easily, very
Yes,
easy
sir.
to solve. You need to consider 64, the prime factorization of 64.
Yes, sir.
More
Can I
easy
use
to
the
solve.
restroom and come see?
Yeah, you just tell me what is the prime factorization of 64. What is the power of 2 you are getting here? Is it the power of 6 you are getting? Tell me. 1, 2, 3, 4, 5, 6. Power of 6 and then power of 1 over 2. You have studied the rule, x raised to the power m raised to the power n is actually x raised to the power m multiplied with n. And if you apply the same rule here, you will get 2 raised to the power 6 multiplied with 1 over 2, that is 2 raised to the power 3, and that is actually 8 you will get. Got it?
Yes.
And even this can be even simplified very easily, because this is nothing but root 64, and this is known as, if power is 1 over 2, that is known as a square root. And here we make pair, and we know the square root of 64 is 8. Okay, I'm just going to tell you some square root. I'm going to tell you some square. If you know the square, you can just tell the square root as well, because
Yes, sir. I know the square.
yeah, square
Square
of,
is
yeah,
always 2 times we need to multiply
yes,
it.
exactly, square
Like
of,
4 square is 4 into 4.
very
6
good,
square
very
6
good.
into 6.
Yeah,
8
but
square 8
but
into
but you
8.
know the importance of this. If you know the square, you can also get the square root. If 1 square is 1, then square root of 1 is 1 actually. If 2 square is 4, then square root of 4 is 2 actually. If 3 square is 9, then square root of 9 is 3 actually. If you know this, you can find out the square root of 1 is 1, the square root of 4 is actually 2, square root of 9 is actually 3. That is the importance. If you know the square, you can find out the square root. That is why generally it is suggested that you remember square up to 30 or 40. Generally people do remember up to 30. I'm just repeating you for you, up to 30 I'm telling you, all right.
Yes, sir. Can I use the restroom?
What are you going to use?
Restroom, sir.
Okay, all right. 5 square is 25. 6 square is how much? 36. And if you know this is 16 is the square of 4, you can just tell the square root is 4. If you know the 5 square is 25, you can tell that the square root of 25 is 5. If you know that 6 square is 36, you can just tell the square root of 36 is 6. Similarly, 7 square is 49, and that is why the square root of 49 is 7. And so far, keep on telling the same thing. 8 square is how much? 64. That is why the square root of 64 is how much? 8. 9 square is how much? 81. That is why 81 square root of 81 is 9. Similarly, 10 square is 100. That is why square root of 100 is 10. Similarly, just keep on solving it. I want you to consider the square root of 30 values and also remember them. I want you to remember them as well. 11 square is how much? 121. That is why if you want the square root of 121, you can just write it how much? 11. Yeah, Pradhan, are you here there listening everything? Listening to me? 144, the square root is going to be how much? 12. 13 square is how much? 169. That is why the square root of 169 is how much? 13. Similarly, the square of 14 is 196. That is why the square root of 196 is 14.
Yes, sir.
Okay. 15 square is 225. That is why the square root of 225 is 15. Okay, I want you to remember up to 30, at least up to 30. Okay, because this is the peak time you need to understand its importance. If you remember the square, it's so easy. In mathematics, many times we can just simplify the value and save our time if you remember all these. Up to 30 you remember the square, up to 10 you remember the cube up to 10, or 20 if you can. 16 square is 256. That is why whenever you get root 256, you can directly write 16. 17 square is 289. That is why whenever you get square root of 289, you can write 17. Similarly, here 18 square is 324. That is why whenever you are having 324 written, you can square root of 324 is 18. Similarly, 19 square is how much? 361. That is why square root of 361 is 19. Similarly, you can have 20 square, that is 400, and that is why under root of 400 here is 20. Similarly, I want you to go up to 30. Okay, I'm telling
Sir,
you
I
ways.
have a doubt in another one, sir.
Okay, no problem. First you cover this. I will consider your doubt. You don't worry.
Yes.
21 square is how much? 441. That is why under root 441 is how much? 21. Similarly, 22 square is how much? Okay, now 21 and 22 start with 4. Okay. Similarly, 23 and 24 start with 5. I'm telling you trick. 25 and 26 square start with
6.
6. Okay. And one more approach is here that I want you to understand. 27 square and 28 square start with what? Start with 7. And 29 square start with 8, and 30 square start with 9. Okay, now I want you to tell me the 22 square. It's actually 484. That is why under root of 484 is 22. Okay, that is why I want you to remember it. 23 square is how much? 529. That is why under root 529 is 23. Similarly, 24 square is 576. That is why whenever you get under root 576, you can write 24. 25 square is 625. That is why whenever you get root 625, you can directly write 25. Similarly, what you get now I am going to tell you one more trick available here. Here we are getting 2 digit as 76. Here we are getting 2 digit as 29. Here we are getting 2 digit as 84. Here we are getting 2 digit as 41. Okay, that means 6. Here we will get 676. 27 square is 729. 28 square is 784, and 29 square is 841, and it is actually 900. Okay, now square root of 676 is 26. Similarly, square root of 729 is 27, and square root of 784 is 28. Square root of 841 is 29. In next class, Pradyumna, I am going to ask all these square root. Square root of 900 is 30. Okay,
Yes, sir.
because I want. Okay, I am not telling the cube and cube root, but do remember, even if you understand cube, it's going to be easy. If you know the cube, let's say I want the cube of 1, you can tell it 1. If you know the cube of 1, you can just tell me the cube root of 1 is going to be 1. This is the symbol to write cube root.
Yes, sir.
If you know the cube root of 2 is 8, you can just tell me cube of 2 is 8, then you can tell me cube root of 8 is 2, because here we make triplet. In square root we make doublet, or you make double pair. Here if 3 cube is known to you, 27, the cube root of 27 is so easy to understand, that is going to
Yes,
be 3.
sir.
If you know the cube root of 4, that is 64, I am telling 10 cube root, you need to understand up to 10 cube, you just remember, that's enough. Cube root of 64 is going to be 4 only. Similarly, cube of 5, do you know the cube of 5?
Yes.
125. That is why you can figure out the cube root of 125 is 5. Similarly, 6 cube, 216. That is why the cube root of 216 is 6. Similarly, the cube of 7, 343. That's why the cube root of 343 is actually 7. Do you know the cube of 8? It's 512, and that is why cube root of 512 is actually 8. Similarly, the cube of 9, how much? 729. That is why cube root of 729 is 9. I will suggest you to remember up to 20, cube up to 20, square up to 50. That's also going to help you a lot in higher classes. But now I just suggest you to remember square up to 30 and cube up to 10 or 15 if you can. 10 cube is 1000, and cube root of 1000 is here 10. Why do we say so? You can just figure it out. Here it means 1000 raised to the power 1 over 3. I am just telling why do we get 10. Okay, listen to me and just focus here. 1000 here means 10 raised to the power 3 raised to the power 1 over 3. Further, it means you need to just multiply the exponents. They get cancelled. You got 10 raised to the power 1, which actually means 10. That is why your result is 10. In this way, figure out the answer. Okay? But I will suggest you to remember all these. Alright, you are okay with this?
Yes.
Okay, in this way, if we understand this concept, we can just figure out what are square, what are square root, what are cube, and what are cube root. We just came to know about square, we just came to know about square root, we came to know about cube, we came to know about cube root. All these things can be easily understandable, we can easily understand all of them. Okay, root 64 is so easy to understand because it is square of 8, we can just immediately write it 8. Either you use the above approach or the below approach, both are same. Okay, now we should solve the second part, 32 raised to the power 1 over 5. Question first, second part can be solved very easily. If we factorize 32, it can be solved very easily. Okay, you just keep on solving all of them. What is the power of 2? 5 is the power of 2. If you want to write 32 in the power of 2, how many power of 2 are there? Tell me how many power of 2 are there?
Yes.
Exactly, 5 power of 2 are there. That means further if you use the rule, which rule? X raised to the power m raised to the power n, that is actually x raised to the power m into n, you will write it as 5 into 1 over 5. That means you got power 1 only, and 2 is your answer here in this case. It is also known as fifth root of 32. Similarly, we have square root, that is 2 root, cube root, that is third root. Similarly, we may have fourth root, we may have fifth root, but we generally deal with square root and cube root. Okay, the next thing is third question. And in the third question, 125 raised to the power 1 over 3 is there, and it also means cube root of 125. What can we do here? We can just figure out that it is 5 raised to the power 3. I have just explained, and that is why it can be written as 3 times 1 over 3, and it can be cancelled, and your answer is 5 raised to the power 1, that is 5.
Yes, sir.
Okay. Now can you solve the second question by your?
Second
Yeah,
question.
I want you to solve the second question and tell me answer. Solve the first one, 9 raised to the power 3 over 2.
Just power 3 by
Yeah, here it is written in front of you. Solve them and
Just
give me the answer.
3 by 2. 3 into 2. 3 ones are 3, 3 to the 6. So
Yeah, you need to just factorize 9. You need not
yes,
worry.
sir.
You need to factorize 9. And you got it 3 raised to the power 2 raised to the power 3 over 2, isn't it?
Yes, sir.
Further, you can write 2 times 3 over
2
2.
times
You
3,
can
sir.
just cancel out these, and you got 3 raised to the power 3. And that is 3 3s are 9 3s are 27 is your answer actually. Can you solve this second part? 32 raised to the power 2 over 5. Can you solve this?
32 raised to the power 2 by 5, sir. 32, just a minute, sir. 32 into 2 by 5, sir.
Yeah, very good.
2, 32 into 2 into 5,
Yeah,
sir.
it's
We need
actually
to
2.
take the
Yeah,
roots. We need to factorize it,
yeah,
sir.
yeah. If we will factorize 32, it will be 2 raised to the power 5. And now we will
Yes.
apply that power rule, and we can
Yes.
just cancel them. We got 2 raised to the power 2, that is 4, isn't it?
Yes.
Can you solve its third part? And its third part is, there are 4 questions here, and here its third part is 16 raised to the power 3 over 4.
Yes. 16 raised to the power 4 by 3, sir. So we need to
No, 3
factorize
over 4.
16, sir.
Yeah, first you factorize 16, very good. And I think you must be okay if I write 2 raised to the power 4 in the place of 16. And further
Yes.
the power is 3 raised to the power 4. How much power is here? 3 raised to the power 4. And if you will use that power rule, you need to multiply these powers, and 2 raised to the power 3 is here 8. Can you solve this question? 125 to the power minus 1 over 3. You know this rule, if power is in negative, what we do to solve such a question? If power
Yes.
is negative, what we do to solve? First we apply this rule, x raised to the power minus m is actually 1 over x to the power m.
Yes.
And it can be written as 1 over 125 to the power minus, now it will be plus 1 over 3. Further, if you simplify 125, can you tell me what is the power of, how can we write 125? Is it 5 raised to the power 3?
5 raised to the power 3, sir.
Further, we can write it as 1 over 5 raised to the power 3 times 1 over 3. 3 can be
As
cancelled.
5,
We got 1 over
125
5.
into, yes, sir.
Okay, now can you solve this third part? Solution third, first part. What will you do here? Will you use this identity? Because your bases are same. That is why you will add their exponent, isn't it?
Yes, sir.
That means we can just
So,
write, we have to add their exponents, isn't it?
yes.
Because power are same. Now how can we add their exponents? We can just multiply these denominator. If we are multiplying denominator, we have to just multiply their cross value. 5 times 2 and here 3 times 1. Is it okay?
Yes, sir.
We got 2 raised to the power 13 over 15.
By 15.
Yeah. Now the second question. 1 over 3 raised to the power 3 raised to the power 7. It can be written as 1 raised to the power 7 and 3 raised to the power 3 raised to the power 7. That can be written as 1 over 3 raised to the power 3 into 7. That can be written as 1 over 3 raised to the power 21. Or if you want to write in negative power, you can write 3 raised to the power minus 20.
Yes.
Got it? Okay. Can you
Yes.
solve this? 11 raised to the power 1 by 2 and 11 raised to the power 1 by 4. Because the power are different, base are same, you will just subtract this power, isn't it? And if you
Yes.
will subtract, you will consider 4. 2 to the 4, you will write 2 here and 1 here. Or you can directly, got it? LCM is 4. Okay? LCM is 4. That is why 2 to the 4. And it's coming out to be 11 1 over 4. That is simplest way. The fourth one, the last one, I want you to solve now. 7 raised to the power
7
1 over 2 and
Yes.
8 raised to the power 1 over 2. You just appear this one and then I will
Since
consider.
we need to just multiply the
Okay, exactly. Their
base
base are different. We will multiply their
and keep
base.
the same. Yes.
Now we got 56 raised to the power 1
56
over 2.
by 1 by 2.
Okay, further if you want to solve this, you can, because it is actually written as root 56. What we can do here, we can just factorize 56. If you factorize 56, you can just do like this, 28, and then you have 14. You can write it as 2 raised to the power 2 into 14. Further you can write as 2 raised to the power 2 into root 14. It is
Sir,
actually
14
2.
is a prime number.
Yeah, 14 is not a prime, but it can, it is 2 into 7. That is why I have not written 2 into 7, because I can't consider pair out of this. I can't consider, I can't make pair out of this. That's why I have written it 14. But we can make pair out of 2, 2 raised to the power 2. We can consider 2 outside. 2 under root, 2 under root 14. 2 root 14 is your answer.
Yes.
Got it? Okay.